Aloha there. We're on to the leap year. I'm going to swear that it talks about leap years in general. When I looked this up last time, but who knows? Then I find this topic pretty interesting, then I could go down to the external resources and see also to see what other things I have. Like, was it century leap year, leap second, leap week? Yeah, because I take it that the reason why this is just called leap year is just because there's more years. There's different types of leaps that happen. So it's not just leap years that are things. It's like one aspect. If I'm explaining myself clearly, if not, just let me know. But yeah, I'm going to. Yeah, I'll just take things in stride for now and see how everything goes. So leap year. A leap year, also known as a interstellar year or bissextile year, is a calendar year that contains an additional day, or in this case of a lunar solar calendar, a month, added to keep the calendar year synchronized with the astronomical year or seasonal year. Okay, so what's the difference between these two? Okay, a year is the orbit period of a planetary body, for example, the Earth, moving on its orbit around the Sun. As you can see over here, when it comes to the Milky Way galaxy, when it comes to the Earth. And now you also have the seasonal year. Yeah, seasonal year is the time between successful recurrences of a seasonal event, such as the flooding of a river, the migration of the species of bird, or the flowering of a species of plant. Because of, because astronomical events and seasons do not repeat in a whole number of days, calendars that have a constant number of days in each year will unavoidably drift over time with respect to the event of the year is supposed to track, such as seasons. By inserting, called intercalating in technical terminology, an additional day or month into some years, the drift between the civilization dating system and the physical properties of the solar system can be correlated. Oh no, corrected. A year that is not a leap year is a common year. Okay, so a common year is a calendar year with 365 days as distinguished from a leap year, which has 366. For example, in the Gregorian calendar, each leap year has 366 days instead of 365 by extending February to 29 days rather than the common 28th. These extra days occur in each year that is integer and integral or integer multiple of 4 except for years even divisible by 100 but not by 400. The leap year of 306 days has 52 weeks and 2 days, hence the year following a leap year will start latter by 2 days of the week. Okay, and then you have more information when it comes to it. When it comes to the Hebrew calendar, yeah, right now I'm just skimming through things. Okay. In the Baha'i calendar, a leap year is added when it's needed to ensure the following year begins on the March equinox. So March equinox is, or northward equinox is the equinox of the Earth when the subsolar point appears to leave the southern atmosphere and cross the solar equator. Alrighty. The term leap year probably comes from the fact that a fixed date in the Gregorian calendar normally advances one day of the week from one year to the next, but the day of the week in the 12 months following the leap day from March 1 through February 28th of the following year would advance 2 days due to the extra day, thus leaping over one day in the week. For example, Christmas Day, December 25th, fell on the Sunday in 2016, Monday in 2017, Tuesday in 2018, and Wednesday in 2019. With the leapt over Thursday to fall on a Friday in 2020. The length of a day is also occasionally corrected by the inserting a leap second in to Coordinated Universal Time (UTC) because of variations in Earth's rotational period. Unlike leap days, leap seconds are not introduced on a regular schedule because variations in the length of the day are not entirely predictable. Leap years can present a problem in computing known as the leap year bug when a year is not correctly identified as a leap year, or when February 29th is not handled correctly in logic that accepts or manipulates dates. Alrighty. So you have the Julian calendar. On 1st January 45th BC, by Edict, Julius Caesar reformed the historical Roman calendar to make it a consistent solar calendar, rather than one which was neither strictly lunar nor strictly solar, thus removing the need for frequent intercalacy months. His rule for leap years was a simple one: add a leap year every 4 years. This algorithm is close to reality. A Julian year lasts 365.25 days. A mean tropical year about 365.2422 days. Consequently, even this Julian calendar drifts out of true by about 3 days every 400 years. The Julian calendar continued to use unaltered for about 16,000 years, unlike the Catholic Church became concerned about the widening divergence between the March equinox and 21st March, as explained as Gregorian calendar below. Alright, Gregorian calendar. In the Gregorian calendar, the standard calendar in most of the world, most years that are multiples of 4 are leap years. In each leap year, the month of February has 29 days instead of 28. Adding one extra day in the calendar every 4 years compensates for the fact that the period of 365 days is shorter than a tropical year by almost 6 hours. Some exceptions to this basic rule are required. The duration of the tropical year is slightly less than 365.25 days. The Gregorian reform modified the Julian calendar scheme of leap years as follows. Every year that is exactly divisible by 4 is a leap year, except for years that are exactly divisible by 100. But these central years are leap years if they are exactly divisible by 400. For example, the years 1700, 1800, and 1900 are not leap years, but the years 1600 and 2000 are. Over a period of 4 centuries, the accumulated error of adding a leap day every 4 years amounts to an extra days. The Gregorian calendar therefore omits 3 leap dates every 400 years, which is the length of its leap cycle. This is done by omitting February 29th in the 3 century years, multiples of 100, that are non-multiples of 400. The years 2000 and 2400 are leap years, but not 1700, 1800, 1900, 2100, 2200, 2300. By this rule, an entire leap cycle is 400 years, which total 146.97 days, and the average number of days per year is 365 plus 1/4 plus 1/100th plus 1/400th equals 365 plus 97th out of 400th equals 365.2425. This rule could be applied to years before the Gregorian reform to create a proleptic Gregorian calendar, though the result would not match any historical records. Because, as it shows, it is complicated that even people just like myself just accept that it's just a leap year. Okay, it's going to happen at some point, like when it comes to leap anything. So leap shifting in the Gregorian calendar, date of the summer solstice over 400 years, has varied between 800, 1900, 2000 to 2200. This graph shows the variation in date and time of the June solstice due to the unequal space leap days rules, contrast the Iranian solar Hijra calendar, which generally has 8 leap years every 30 days. Okay, let me actually see what this one is. I think this is just referring to the leap years. Okay, it's a solar calendar in which one of the various ancient Mediterranean calendars. Okay, so when it comes to solar calendar. Okay, yeah, this pretty much brings out the gist of what solar calendars. I figured that that's an article I might stick with in the future. Ugh. The Gregorian calendar was designed to keep the vernal equinox on or close to March 21st, so that the date of Easter celebrated on the Sunday after the eschatological full moon that falls on or March 21st, so that the date of the Easter. Actually, no, I'm starting to. Hold up. Alright. Let me repeat this paragraph. The Gregorian calendar was designed to keep the vernal equinox on or close to March 21st, so that the date of Easter, celebrated on the Sunday after the eschatological full moon that falls on or after March 21st, remains close to the vernal equinox. The accuracy section of the Gregorian calendar article discusses how well the Gregorian calendar achieves this design goal and how well it approximates the tropical year. That's the Gregorian calendar, like, pretty much in quotes. Wouldn't it also be just the article? Strange. Okay. After following all this, we pretty much have the separations between the Julian and Gregorian calendars. Yeah, just going through this time. There's some similarities, but there's not. A Swedish pocket calendar from 2008 showing February 29th. Cheeky. And I figured I'd also go to old pictures. So an image showing which century years are leap years in the Gregorian calendar. Mark's correct, so XXX. Leap years occur mostly every 4 years, but every 100 years we skip a leap year unless the year is divisible by 400. Alrighty. So yeah, after going through all this, Julian Gregorian calendars, they have the same issue. They try to follow some things, some variations. Early Roman practice. The early Roman calendar was a lunar solar one that consists of 12 months for a total of 355 days. Okay. They have 10 days fewer than what the modern world usually follows, following a Gregorian calendar. Okay, following the Romans when it comes to adding this. You have like the Julian reform. Actually, you know what, let me just skim through these to see if there's anything I should follow. These talk a lot about calendars. I mean, it made me very interesting when it comes to following this because it could follow me to a start. A start in me understanding what calendars are, so I could learn more about leap years and then compare and contrast. Because when it comes to the Julian and Gregorian calendars, there's some things I just didn't know, but just because, you know, I didn't start out learning more about calendars until I actually read to a main article that talks about it. All just because I was interested, like, well, what is a leap year and such. I'm also trying to I'll be comfortable doing this next time, making sure I get my strength up and stuff. And also get some rest. Always feels like I need it. So yeah, next time I'll just follow up solar candles this time. And then talk more about leap years. I read through some, understanding the complexity of it, When it comes to his background history, I don't have that prior knowledge. So solar calendars, that is what I'm going to learn next time to understand more of gist. The gist info about leap years. Well, further ado, aloha.